We've all been here before, stuffed our faces so full we hardly feel like moving, almost at times as though we literally can't move. Humans are not the only species to engorge themselves. In fact, many other creatures do this to a much more extreme extent. Take, for example, a member of the Annelid phylum, and more specifically, the Hirudo clade, the medicinal leech, Hirudo verbana. Shannon Jerry and David Ellerby have looked to see if serotonin impacts muscle function during and after feeding.
These leeches have a somewhat unique feeding behavior. They can consume up to 10 times their own body weight in a single meal. Let's put this into perspective. The average person eats 4.7 pounds of food a day. This means that someone weighing 160 pounds would need to eat all the food they would consume over the course of 11 months in a single feeding. Imagine how much larger you would have to be afterwards. This large change in volume of the leech actually poses a mystery to those that study leeches. The change is so extreme that it affects the body wall and the muscle function within it. Before we go deeper, let's talk a little bit about muscle. Inside a muscle, there are tiny groups of proteins called sarcomeres. These sarcomeres are primarily composed of thick and thin filaments. The thick filaments have many tiny little heads called cross bridges, and these cross bridges grab on to special spots on the thin filaments and then bend backwards, pulling the thick filament along the thin filament, similar to a person climbing a rope. The more cross bridges that connect, the greater the force the muscle can produce. So what does this have to do with leeches? Well, as the leech feeds and its body is stretched, these muscle microstructures begin to pull apart. As they come apart, the number of cross bridges grabbing onto the thin filaments becomes fewer and fewer. This means that the muscle can produce less and less force. The degree to which a leech stretches should leave it very vulnerable, almost immobile, and yet the species persists. Jerry and Ellerby predicted that serotonin may have an impact on muscle function. You may have heard of serotonin before, also called 5-hydroxytryptamine, or 5-HT for short, as it is a chemical found in many other animals, including humans, and has recognized roles in the digestive process. They predicted that muscle tension would increase in the presence of serotonin, allowing the leech to be able to move and escape predation.
To test this theory, Jerry and Ellerby started by attaching sensors on the bodies of several leeches. These sensors communicated and gave information on how much space there was between them, and thus how much the muscle was stretched. These measurements of live leeches provided muscle stretch data on swimming, crawling, feeding contractions, and post-feeding stretch. Next, strips of muscle 3 segments long were cut from the leech's dorsal side. The anterior and posterior segments were wrapped in aluminum foil conductors, and the middle segment was measured. The strip of muscle was submerged in an ionic bath to recreate the leech's internal environment. The experimental baths also contained 10 micromolars of serotonin. While submerged in the bath, the passive tonus was measured when the muscles relaxed, and the active muscle tension was measured when the muscles were stimulated, aka shocked.
The results were not exactly as predicted, but they were close. What they found was that serotonin made relaxed muscle more relaxed and active muscle more active. This increased range of muscle tension between relaxed and contracted, which enhanced the leech's ability to swim or crawl. So what exactly does all this mean? Well, the presence of serotonin increases the muscle's ability to do work and move the leech, allowing it to swim and or crawl after feeding. This evolutionary adaptation allows the leech to escape and safety and survive.